Here we are on Center 1, Air and Sound.
Hey, welcome to Center 1, Air It Out, for our Air and Sound unit. The goal of this center is to learn about the several different properties that air has. The basic properties of air are that air has mass and volume, air exerts pressure that creates lift, which is how birds fly, and air contracts and expands, which creates wind and weather. This center includes 4 short activities that demonstrate these properties. You can choose to do all of the activities or parts of them, and just figure out a set that works best for you to explain the properties of air. So when you open up the box, it's divided into the 4 different activities, A, B, C, and D, and they're labeled in Ziplocs and then in the container.
Oh, that says A on there somewhere. There it is. Okay.
So A is air pocket, and its purpose is to show that air has volume and occupies space. So you'll need to fill up this plastic container with water, and you'll need to fill it up probably about halfway. And then you'll need to get a cup and stuff some Kleenex in there,
Oh, I missed that.
and tape the Kleenex. Just, you don't have to really strongly secure it, just secure it enough that it won't fall out. And then you're going to ask the student to hold this glass upside down and push it straight into the water. They need to go straight in, and you can hold it there and then bring it out and ask the students to check whether or not the Kleenex is wet or dry. And if you've done it straight down, the Kleenex should be dry. As you do it, you might ask the students for some observations about the water level. The water level goes up. You might ask students to think about, is there any water inside the glass? And you might ask them to predict whether or not that Kleenex is going to get wet or not. So the Kleenex isn't wet, and why is that? Well, it's because the air in here displaces the water in the container and forces the water away and keeps the Kleenex dry. So thus proving that air has volume and occupies space. You can illustrate the same thing with a Ziploc bag and fill it with air and zip it shut, and then ask, of course you could fill it with more air than that, but have the kids squeeze it, and you can't squeeze it too tightly. I mean, you could pop it. I'm sure everybody's done that. But the idea is that, again, the air is taking up space and volume. So that is part A. Part B is bottled air. Bottled air you will need.
I can't move that and record. So sorry. There you go.
Let's get this. Okay, so you start out by asking students with this bottle if they think it's empty or full. And it's a trick question because, alas, there is no Gatorade, but it is now full of air. So it is full. Then you're going to get a balloon and you're going to blow it up just part way. And it blows up pretty easily. There's a lot of air that I can displace around it, and a lot of places for that air to go. If I take that same balloon and I stick it inside of my bottle and try to inflate it, that's as far as I can get. So the question you need to pose to the students now is, why can't we blow it up? What's going on that I can't blow it up? And the answer is that this bottle is full of air, and all the air is contained in there, and there's nowhere for that air to go to be displaced by the balloon. So even though air is invisible, it takes up space. So that's part B. C is killer straw. And you will need to bring a potato from home. And when you're done with your potato, you'll need to just discard it or feed it to some chickens. And you'll need a straw. So this one illustrates the push of forced air or air pressure. So you place your potato on a tabletop, and you're going to have a student hold a straw at the top of the potato without covering the hole, and have the student try to stab into the potato. And it goes in. And then you're going to need a Sharpie.
Oh, where did I put them?
And you will take that Sharpie and you'll make a little line on the straw. Maybe a black Sharpie will be provided later.
I know there's one here somewhere. Oh, there it is.
Dun-dun-dun.
Dun-dun. Here's some Sharpies. Okay.
Sharpies, cool. So it went in that far. I was able, without covering the hole, I was able to stab the straw in that far. So now, have another student put their thumb on top of the straw and pick a different spot and stab it in. And it doesn't go in as far.
Wow.
Why is that? So you ask the students, why is that? Why did the cap straw not go as far in? The air, again, was trapped inside of the cap straw. It had nowhere to go. So you could only force so much of it, compact it so much, and that's why it didn't go in as far. Again, show the difference. Oops. It's not a huge difference, but it's a difference.
Very fascinating.
Da-da-da. You could make French fries. No, just kidding. Okay. So then part D is called rising waters. So rising waters, you will need the square Tupperware with a candle. You don't want the candle floating. You want just enough water in there to go up the sides of the candle. So you're going to need to light the candle on fire. And you're going to need your glass jar. You need a glass jar, not a plastic one, so that you don't melt stuff. And I've put some food coloring in the water so that it's easier to see the water level rise, hopefully. So light the candle and get it going. And you might start out by just a brief, quick discussion or a question. Why, what does that candle need to burn? And have them brainstorm a little bit. And they might say air, they might say oxygen, they might say fuel. So after it's going a little bit, you're going to take the glass jar and go ahead and put it on there. And when all the oxygen is used up, I don't know if you can see the water rise. So the candle goes out. Oh, yep. The water is actually rising inside and going up the candle. Can you see that?
I don't know if they can see that, but it's way up almost to the top of the candle now. I don't know if you remember when we put the jar on, it was at the bottom of the candle. So the water level rose inside the jar.
So, why is that? Questions of why, lots of why questions. So when if air is made up of oxygen and nitrogen, all the oxygen got used up when the flame in there used up all the oxygen, and when it was gone, the flame went out. So now all that's left in there is the nitrogen, and the air pressure inside the jar is now less than the pressure outside of the jar, And so that's why the water climbs up and pushes, and water gets pushed into the jar. And that, in a nutshell, is Center 1.
Yay, Center 1. So if you have any questions, you can email us at mitchellelf@gmail.com. Thank you.